All right, here are some properties of dot products. First of all, we can do the commutative property. So to change the order of the dot product will be the same. We can do the distributive property. If I have the dot product of a vector and then of sum of vectors, I can do the dot product with v plus the dot product of w, and I'll get the same scalar. Scalar multiplication. If I'm taking some number times a dot product, I can do this number times u and then do the dot product with v, or I can do this number times v and then do the dot product with u, and I'll get the same answer. If I do the dot product with zero vector, I always get 0. And I just realized that there should be a 0 on here. 0. I always get 0. All right. These don't really come up very often. There's not a lot of problems that actually involve those. This is what you're going to see. Dot product and vector magnitude relationship. Okay. If I take the dot product of a vector and itself, it's the same as the magnitude, that's what this is, squared. So if I take the square root of both sides, if I take the square root of their dot product, that's the same as their magnitude. And that's what they're going to ask you to do in the homework. Use the dot product to find the magnitude of vector A. Okay, now we can do the square root of a squared plus b squared, and we can get the magnitude that way. Or, since we're doing dot product, you're going to take the square root of the dot product. So the square root of the dot product is going to be -5 times -5 plus 12 times 12, which is the same exact thing as the square root of a squared plus b squared. Okay, so I have the square root of 25 plus 144, or the square root of 169, which is 13. So the magnitude of vector A is equal to 13. Its length is equal to 13.